Thank you all for showing up. This is the last presentation of this conference, so I appreciate your presence. My name is Rellermeyer. I'm with IBM Research in Austin, Texas, and I will talk about lean and easy IoT applications with OSGi and Eclipse Concierge, of which I'm the project lead. Greetings from our IBM lawyers. So who of you here does not know OSGi? Yeah, okay, I will give a brief introduction, not make it too long, right? Oops, that was not a good idea. So OSGi and embedded, it's kind of curious to see how OSGi has developed over time, because these days it's definitely more popular with large applications on the server side. Applications having a lot of bundles like Eclipse, right? But it all started in embedded because one of the first applications that OSGi, or the Java application server, was developed for was actually television set-top boxes, and that was what people thought would be the smart home of the future, right? Because everybody had a TV, and that would obviously be the gateway to everything of the future. So you put a smart device on top, you have a screen, you have intelligence, and now you can control your smart home. Well, then came the smartphone, right? And this plan didn't work out. But the interesting thing is these devices have kind of inherent properties that make them rather difficult to deal with, right? Because very often they were provided by, let's say, a cable provider or a telephone company and so on. So strictly, they were not owned by the people who would use them. And these providers would want to do frequent software updates and maintenance for security reasons, to give better user experience and so on, right? At the same time, they try to be kind of open ecosystems where you could plug in additional intelligence, drivers for other smart home devices, or even maybe your own stuff that you have developed. So you run into the problem of basically software update management, right? And if you want to really understand what the core of OSGi is, just take the opposite of it, and that's the Windows restart button, right? Whenever you do an update, you have to do a restart. OSGi solves this problem because instead of having one monolithic application that can only restart as a whole, OSGi helps you to modularize your application. Modules can interact, but these interactions are exposed because modules are isolated, and whenever you share something, you have to explicitly declare it, right? And that way you have a piece of software that is called the framework, which can actively monitor the connections between your modules and therefore do better than doing a full restart. It's kind of curious that one of the most popular OSGi applications, which is the Eclipse IDE, still has a restart button whenever you do an update, right? It's not because of OSGi, it's what happened when you keep too much state outside of OSGi, right? But that was where it all came from. And then OSGi just grew bigger and bigger. It was embraced by the Java application or large-scale application server middleware community, a whole lot of different applications by Eclipse, right, which made the framework much more complicated to drive such a large application. The footprint grew, and my take initially was that this is no longer ideal for embedded systems because you get software that is a little bit too heavyweight to really run efficiently. And that's why I started Concierge in 2006, which initially was a research project that I did at ETH, and it was a full implementation of the R3 core specification in 83 kilobytes, which at this time was a lot less than the competitors, and that hasn't become better. So what is OSGi about? At the lowest level, as I said, you have modules, right? You have the framework, which is managing this module, and now you have basically a way to actively manage the lifecycle of software components, in that you can dynamically at runtime load new components, you can exchange components, and then have the framework just restart the part of the system that is really affected by this update, or you can get rid of stuff, right? All in a long-running context as a set-top box, which basically you would never want to reboot if you can avoid it, right? The key thing to getting this implemented is that, by default, modules don't share anything, or bundles don't share anything, as they are called in OSGi. If you want to share content, that's happening basically at the granularity of Java packages, and you have to explicitly declare them as imports and exports, right? I have another image which kind of shows the relationship of that. The key thing is, because you can now dynamically manage the software lifecycle of your component at runtime, it's no longer a reasonable assumption that it will never change, right? Therefore, you should always embrace the inherent dynamism of an OSGi application. And the best way to do it is just prepare to handle events, right? Because whenever something is updated in your system or changes, there will be an event. Code your software in such a way that you can deal with it actively. And now you have a system that overall is much more robust, right? So this is just a little picture that shows an OSGi application in action, right? You have 2 or more bundles in this case, right? These bundles provide packages, and now some of these packages are marked for exports, which means they are visible to others, right? And whenever they decide to import, the framework will take care of wiring these 2 together, and then your separate class loader per bundle has a path to access classes of the other bundle, right? But by default, because they are separate class loaders, nothing is visible. And yes, separate class loaders is key to actually unloading stuff, right? Because as you possibly know, a class loader will never forget a class that it has once loaded. So the only way to get rid of a module is have a separate class loader and make sure that this can be thrown away as a whole. All of that will be garbage collected, and you actually restore your system to the state prior to installing the piece of software. Okay, so this is kind of the easiest case, right? Now, maybe in an embedded device, this is still realistic. The more your application grows, the more you get into app servers, the more you will have the situation that your bundles are no longer really unique, right? Because they might have overlapping content. Best example for that is, you have an app server and you're running several versions of Log4j. Why would you want to do that? It's not that you really want to, it's that you're using libraries that have different dependencies, right? And you get the value of the library only if you can somehow provide these dependencies in the right versions. So another really useful feature of OSGi is an active way to manage versions, which honestly is something that Java out of the box does not support at all, right? Because of the flat class path and because nothing is really versioned in Java, right? So in a realistic scenario, you would not only export a package, you would export it under a certain version and then you import it with a certain version range. And that automatically makes sure that you get wired to the correct version. And it also solves the problem by keeping those spaces of visibility separate, that you're not running into a situation where you see 2 conflicting versions, which would possibly make your application crash, right? It's a linkage error. So OSGi can run multiple versions of the same thing at the same time and expose it to different applications. There's absolutely no problem at all. So in some sense, it is also an elegant way to make sure that you have a single Java virtual machine and you don't have to artificially split up your components into multiple virtual machines, which, given resource-constrained devices, you really don't want that, right? Okay, now if modules were the only thing in the universe, in the OSGi universe, you would get all these additional features for active management, but still it would not be very modular and not be very dynamic. Because at the end of the day, package dependencies are explicit and they have to be fulfilled in order for a piece of software to work, right? You cannot make them optional because in the end, that's basically a link level dependency, right? You cannot run your package if this other package is not installed in the correct version at the same time. So there's another layer at which you can do this more dynamic composition, and that's basically enabling all the use cases where things dynamically come and go, and you might actually be able to live without a certain software component being installed. You can dynamically install it, and then for a certain period of time you have additional functionality, but it's not mandatory, right? So in an ideal world, logging would be something like that, right? Because your piece of software can run without logging, and maybe you just want to dynamically log it when you really care, right? So that's definitely possible if you buy into OSGi services, right? Now, think of services in the context that is much more low level than what services in SOA or microarchitecture are, because we're coming from an embedded systems world, right? These services are absolutely no proxification at all, right? These services, at the end of the day, when you receive the service instance, are plain old Java objects. So, there's a certain boilerplate code overhead involved in acquiring a service, but once you have it, there's absolutely no overhead in using the service, right? Because the early devices that OSGi was designed for could not have afforded that, right? So, the entire art of using services and why it leads to a more loosely coupled system is that instead of having a package level dependency and therefore basically having a dependency to particular implementation, you can abstract away from implementations by designing service interfaces. And interfaces naturally have much less dependencies because they only provide you the API basically, right? So then you will ask for a service by its interface and what you get is an implementation, right? Therefore, you only couple to the interface, not to the implementation, which, you know, makes your overall coupling more loose and also enables you to run without an implementation even installed because the interface might be there and that's enough, right? And you can deal with situations where you have multiple providers of an interface very easily and elegantly. So it's just all the benefits of loose coupling versus, you know, a purely modular system which would implement tight coupling. Okay, so what is OSGi good for in an IoT context? Well, just one example, right? Very often you have sensors and actuators in your system if you're designing an IoT system, right? Unfortunately, those are mostly end-to-end relationship between basically consumers and producers, right? So if you implement something like that in practice, you might think that, well, maybe the consumers can just register with the producers, and then the producers keep track and they deliver the results to the consumers. Well, that's okay if you can always ensure that there's at least one producer, right? Because if there is not, where do the consumers register with? There's nothing in it, right? Plus, if a new consumer comes in, you know, you have to track that and so on. It's a little bit of a bootstrapping and chicken and egg problem, which is why in the larger scale, people usually use message buses of some sort, right? That's basically a mailbox pattern. So you have an independent entity in the middle that keeps track of the membership and then you do publish subscribe, right? And that's fine, except that if you happen to be on the same platform, because it's a single JVM, right? You still want loose coupling, but you don't want, you know, sending HTTP messages to yourself, which is completely overkill, right? So the service registry in OSGi can serve as such an independent entity, basically as a message broker, right? And that is a pattern known in the OSGi community as the whiteboard pattern. So instead of having explicit tracking of membership and so on, you know, the producers will simply register themselves. The consumers will simply register themselves with the software, with the service registry. And then the producers, whenever they are ready to produce, they will just look up who is currently registered to consume and deliver the results there, right? And then there is a service tracker which kind of encapsulates this in a nice way. And when you first registers it, it gives you a snapshot of the current state, which can help you to just bootstrap your problem because maybe you want to prime the consumers with the history of the last minute of sensor data or whatever, right? This pattern makes these loosely coupled systems a lot easier in practice. And as I said, without any overhead, because a call to a service is just calling a method on a Java object. You cannot get faster on a JVM than that, right? Okay, so what is Concierge? I already told you that it was basically my effort to make the footprint of OSGi smaller and make it run better on small devices. I started off with 83 kilobytes for R3, and then at a certain point we kind of rebooted the project under the umbrella of the Eclipse Foundation for IoT. And we try to get full R5 compatibility, right? So R5 is significantly more complex because it introduced versioning and, you know, generic capabilities and so on. So we are pretty happy to report that it's still 250 kilobytes. Actually, it's even a little less. I like to throw stuff out as I make changes to the code. Or if you really need debug symbols, then 330 kilobytes. That's pretty significant. If you just take the OSGi API, that's already a good portion of that, right? So I would think it's really hard to get smaller than that. Another thing that was nice about the old implementation is that actually a lot of people used it to educate themselves about OSGi because it had only a handful of classes as opposed to, you know, the larger implementations which can easily have 50 or 100 classes. You can look at the code and actually follow through what an OSGi framework does internally. And we try to maintain that by still only having 9 classes, plus I think about 45 inner classes, which is in the nature of Java that you need that frequently, but I think it's still readable, right? So if you want to find out how a specific feature in OSGi is implemented and works and learn about it, you know, look into the code. It's not that difficult to understand. The original version was backwards compatible to some of the most weird JVMs that were ever developed and produced. I had all these nice embedded and you know, mobile devices that I was playing with. That included an old Z-Man SimPad, if you have ever seen it. That was a tablet before people even talked about tablets. And it had a really strange version of Java, which was called Personal Java. Technically something between Java 1.1.8 and Java 2, so not even collections. That really was a difficult platform to deal with. But you know, it was cool for demos, so we made the code in such a way that it would run basically up to things that were borderline Java 1.4, right? In the meantime, the world has progressed. We initially thought supporting Java 4, but honestly, after we had compact profiles and so on, it seemed reasonable to make the leap to Java 5 eventually, right? So if you really wanted to run it on 4, it would be just a few changes that are necessary, but so far we didn't see any need to do it. Okay, so what can you do with Concierge? Well, our committers all use Concierge on an almost daily basis. So we put a lot of emphasis in actually making it usable in a reasonable way on embedded devices, right? And the first thing is you want to make it easy to just start a new deployment and build a new application. So because we are dealing with low-level devices, to us the most natural way is you just write a configuration file, you deploy the jar files, the bundles, and you know, you would expect it to work. So we support primarily the Knopflerfish style xargs file as a startup argument. You just list all your bundles in which start levels you want them to be started, and that way you can deploy an application pretty easily. We did a couple of extensions to this file format, which seemed very useful for our use cases. For instance, you can use wildcards in the bundle names. This is really awesome if you're dealing with you know, a continuous integration system where your jar file names tend to be, you know, like 500 characters long and include various version strings, right? So if you use anything that the file system can order correctly, the wildcard will make sure that you're always running on the last version of the bundle without any further ado, right? Another thing is we have basically variable replacement. So, you know, in this example, it's extremely easy to switch from a local deployment to, you know, a web-based deployment, depending on whether you want to give a demo in a system where you have internet access or not, right? Those are just a couple of productivity tweaks that we found really helpful for our daily life. Another thing that we added, I at one point wrote a specification for the OSGI Alliance about a RESTful interface that allows you to interact with an OSGI framework, monitor the state of your bundles and services, and even do installation tasks over basically a web-based interface in the end, right? So we thought this was a great substrate out of you could build command line tools or, you know, even web interfaces in a standardized way that works with any backend, or even if you want to do it on a cloud, right, where, you know, basically HTTP is your only choice. So this is also available in Concierge. I wrote the reference implementation and it's integrated in our repository, and we will release both the service and client reference implementations with the next minor release. We even have a JavaScript client just for the purpose of showing that this is indeed possible with the REST-based interface. Okay, so let's get into a use case. One of the people who contribute to our project works for Eclipse Smart Home, or more precisely for Deutsche Telekom, who is building a commercial product that is backed by the technology of Eclipse Smart Home. And they went through the exercise of taking their existing reference implementation, OpenHAB 2, and basically exchanging their OSGi implementation with Concierge. And as part of this larger effort, they actually found a lot of things that they could get rid of in order to make the entire deployment smaller and faster. So, you know, they took some of the modeling stuff out, they took some of the carafe stuff out, because they basically could achieve similar things without using some of these more heavyweight components. And in the end, they managed to run on up to Java Compact 2 profile. And you see, you know, the memory footprint has basically been sliced in half, and the startup time has improved by 10 seconds, which, you know, for a consumer-grade device can be pretty significant, right? People get easily annoyed if they have to wait for devices to start up. So I think that's a pretty compelling use case. Another thing that another committer of us, Tim Verbelen, is doing in his lab is basically using Concierge on embedded devices for machine learning. So they have their own, I would call it IoT lab kind of interface in which they can compose standard services that they have written. And it's all running on Concierge. And the nice thing about this is both I and Tim have in the past worked on things around OSGi remote services. So with that technology, and if you have a pure OSGi application, you can basically seamlessly move services between devices. If a certain device does not have all the capabilities, for instance, to do machine learning algorithms efficiently, you can just outsource it to a device that has a strong GPU, right? Or if you don't even have that, you can just move it to the cloud if your connection is good enough, right? So you get all these degrees of flexibility. And I can just show you one service or example that they built. So in here you have this NVIDIA Jetson device, which is an embedded device, an ARM device that has a pretty significant GPU on it, which you can use for machine learning, right? Programming CUDA. They have Raspberry Pis that control, you know, Philips Hue, and they have a robotic arm, and then they have a camera which takes pictures. And, you know, just for the fun of it, they implemented an orange detector that is basically, you can put fruits in front of the sensor and then it will decide whether or not this is an orange, right? So, oh, I should have clicked on the video. So, yeah, you see this in action here, right? This is not an orange. This is actually a lemon, so it will be rejected, right? And now test it with an orange. And you see light turning its color, so this was detected, right? It's a fun little application, but point here is, you know, you can really exploit the different capabilities of your devices and federate your devices very easily if you buy into the OSGi service model. And, you know, Concierge is easily able to run on all these devices. Okay, another thing that you might have heard is OSGi en route. This is a technology that OSGi is developing in particular for things like IoT. It does require OSGi R6 as a framework, but we have a branch that is already pretty compliant with R6 in our repository. And if you take a snapshot out of that, you can easily run the OSGi services on top of it and have a deployment of en route that is very nice and easy and lean and works very well. So I talked a lot about performance. It's time to get some numbers, right? And that's always the core of my presentations. I have two devices that I've been using for a long time, and you know, every time I show them, I realize that I should buy new ones because they are a little dated by now. But honestly, that's good because, you know, newer devices tend to have more resources, right? So we have a BeagleBone Revision A5, which is has an embedded ARM Cortex. You know, not a lot of memory, but it's running a more complete version of Linux, right? And then we have a Raspberry Pi B, which has an ARM 11. It has more memory, more storage, and it's running Raspberry Linux. And I run, I would say, typical JVMs on those devices. So the nice thing for BeagleBone is that you can easily build a Compact 1 profile out of Java 8, right? And then I have just a Java SE embedded 1.7 running on it, which was kind of particularly built for this platform. And as a new addition, I also ran it with Zulu embedded. This needs to take the soft-float ABI. The Raspberry Pi, this just has a standard Java SE provided by Oracle for this platform. And it also runs Zulu, but with a hard float ABI. Okay, so in my experiments, I compare to the most popular alternative OSGi framework implementations, which are indeed Eclipse Equinox. That's kind of one of the latest versions that I use. I always try to, you know, be on the latest and greatest. This is a full R6 framework, so it's not apples to apples comparison, but honestly, the difference between R5 and R6 is not that big. So, I think it's still fair. Apache Felix, this is the latest version that they just released this year. Knopflerfish, which is another open source implementation in its latest version 7.2.0. That's the latest R5 version because they have R5 and R6 in parallel, right? And then Concierge, which is basically the latest snapshot build of the 5.1 release that we are currently planning to release very soon. And you already see that, just the raw footprint of these framework implementations is pretty different, right? Now, the first thing that you will experience when using an OSGi framework is the startup time, right? Because that is considered pure overhead from, a human-computer interaction perspective, right? So in black here, you see the overhead of just starting the particular JVM on the device. And then you see, how much more startup time the different OSGi frameworks add. And this is basically why some people don't like to use Equinox on embedded, right? Because it takes a long time to actually start up, right? We optimized our code pretty extensively for those devices. That's why you see that we are consistently the fastest framework in startup time. And if this is maybe 1 second, we take 3 to maximum 4 seconds. That's very reasonable delay for human interaction. The next thing, and one of the things that really matters at runtime of an OSGi application is the performance of the service registry, right? Because remember that those are the kind of interactions that happen while the application is running, right? And the more you loosely couple your system, the more, let's say, end-to-ends you have in your system, the more stress you will put on the service registry. And, with limited memory, this is something that can easily add to delays. So we have created a stress test, which, by the way, is also available in source code in our repository. And this just registers 10,000 devices. Services in OSGi can have properties attached to them, which you can match by filters. So in order to incorporate that, each of these service instances has a random value for the same exact key. And we use byte as the data type, which means, 256 states, 10,000 services, about 39 to 40 instances if we have a perfectly random distribution, out of which every service lookup will have to pick, right? So, we just do the registration, measure this time, then we do 1,000 lookups, which gives us 10% of the services that are registered, again with filters in the byte range, and ultimately unregister the 10,000 services and measure this overhead. So the first thing, registering the services, you see that, especially on the devices which don't have a very optimized JVM, the difference can be pretty significant. And again, we are consistently the fastest framework among these things. You will also see Equinox being absent from the embedded, that's the Compact 1 profile on a couple of slides. This is simply because of unknown reasons. Equinox doesn't run on Compact 1 anymore. It used to work, but at a certain point with some release, something broke and it just doesn't work anymore. So I think this is pretty promising. Registering services is fast. Lookup is even more important, right? Because that's actually the high volume operation in a loosely coupled system. To the continued surprise, Felix really has problems with service lookups. And even though, I know all of these people personally, right? Whenever I talk to them, they tell me they have optimized so many things, but, I repeat my measurements for every talk and this picture doesn't really change. So this is kind of the outlier. Then if you would zoom this up, you would see that, this is still a 2/3 relationship at most, maybe 50% of the time compared to the other frameworks that are not named Felix. And ultimately, service unregistration, again, you see a couple of outliers. This picture is more scattered, right? You see that for some reason on Raspberry Pi, Equinox has a bit of a problem with service unregistrations. And that's another important message to take away, right? Sometimes it's not only about raw performance, but it's also about the predictability of performance on different platforms, right? And the more heavyweight the structure of the OSGi framework and the applications are, the more they rely on just-in-time compilation to basically clean up performance problems, the more you will see an inconsistent picture with various degrees of optimizations that you can find on these platforms. All right, one more round of performance comparisons. This time it's the resolver, right? Now, resolver is basically what happens if you install the modules and the framework tries to find a wiring for you to make all these requirements fit. Again, we designed a scenario in which we put this part of the system under stress. We generate 10,000 kind of random bundles, which means we basically generate random metadata, synthesize them, and then materialize jar files out of them, right? We have a certain amount of packages that can be either imported and exported, 50 packages in total, and every bundle can export and or import up to 5 of them, right? And thereby we get kind of a random scenario. We also generate version ranges and so on. So the scenario here is install all these 10,000 bundles. This is an operation that is mainly I/O bound because OSGi mandates that your bundles are getting persisted locally. They could potentially come over the air, so you know they have to be there for restart reasons, and then do the resolving. Now, if you would do all of that with perfect random distribution, the benchmark is very volatile, right? Because the different instantiations of these random distributions have very different properties in terms of resolving. And you would have to run it a lot of times to get stable numbers. That's why, at some point we just materialize one randomly generated configuration that is kind of typical, and we supply it as a binary string, and the benchmark will recreate this exact scenario every time that you run it. So, bundle installation, again, you see some outliers, and Concierge is consistently the fastest framework in this regard, which is interesting because in the end, the speed of light here is really how fast can you write to the storage device. But we optimize that quite a bit. And again, you see a very consistent picture among these different platforms. And then bundle resolving, this is the only slide where you see other frameworks occasionally being faster, right? And that is, especially those frameworks that are designed for larger deployments, they tend to cache intermediary results more aggressively, which we don't do because our assumption is that memory is scarce and we have to save it, right? Because otherwise you will resolve very quickly, but then you hold on memory that is not available for the application, which we don't measure here. So we are glad to be pretty much on par with the other frameworks, even though we have taken more careful optimization steps. All right, so that pretty much concludes my presentation. Concierge is available for download if you just want to try it. It's very optimized for small devices, the Internet of Things. You can find it on GitHub, clone it there, and I just encourage you to give it a try, right? And of course, don't forget to rate even the last presentation of the day. And with that, thank you very much, and I'm happy to take a few questions. Yes?
About the REST API that you were mentioning, how much stable is that? Is it just something new that is in this version and might change? You said at some point that you have submitted it.
I think I wrote the first specification 6 years ago.
Okay. Is it still like that?
It's still like that, yeah. It's, it is now an official specification, right? That speaks a lot to how slow standard organizations are to accepting things.
In the implementation side, is it just you implementing it, or?
No, I think there are other implementations out there by now, right? But I think at least some of them are kind of hidden within web management frameworks. I'm not sure if they also expose the services or if they are just using it. Yeah. So my reference implementation is based on RESTlet, and we have a one bundle deployment. You just throw it on the client and the server, and that's it. Mm-hmm. Yes?
Another question.
Yeah.
About just-in-time computation.
Uh-huh.
In all those measurements.
Yes.
Did you just use defaults for all those?
Yeah, I'm not using any particular tunings. No, I'm just out of the box via. Yeah. Any other question? No? All right. Well, thank you very much.